Question 81. If function f has a removable discontinuity at x equals 3, which of the following could be the graph of function f? Look at all of that. If you look at that, what difference between A, B, C, and D? You're going to find that if we have a vertical line here and here, you're going to see that the function, the limit of the function doesn't exist. The limit of the function doesn't exist here. Because you have from left doesn't equals right. And here is also the limit doesn't exist. Also here, the limit doesn't exist. If you come to C, you will find that the limit from right and left are equal, removable. So the answer for this is C, because the limit exists. Removable discontinuity, yes, is discontinuous, but the limit exists. That's the question 81. Question 82. Integrate the function f continuous, and we have the integration from 0 to 17, from 17 to 20, and we have from 13 to 20. Find from 0 to 13. So we have to find the strategy how to get from 0 to 13 here. So we know that the integration from 0 to 20 f of x dx equals the integration from 0 to 17 and from 17 to 20. Plus the integration from 17 to 20. We know the value here is 8 and the value here is -3. Combine it will be 5. So this is 5. And actually we need it from 0 to 20. Yeah, because from 0 to 20 we could divide it into from 0 to 13 and then from 13 to 20. So let's do that here. A different color. The integration from 0 to 20 of the function x could be represented differently. It would be from 0 to 13 of function x, f of x, and from 13 to 20. We know that, which is 7. We don't know this. We need it here. And we know from 0 to 20, we just got it, which is 5. So 5 equals a number plus 7. This number is -2. So the answer for this is A. That's the question 82. Question 83. The multi-step function k to the third plus x and from 16 over k squared minus x around x. That's when x is less than 3. That's when x is greater than or equal to 3. Let f be the function defined above, where k is positive constant. For what value of k the function continuous? The function continuous means limit of step 1 equals limit of step 2. So limit of step 1, k to the third plus x when x approaches 3 equals limit of step 2. Step 2 is 16 over x k squared minus x when x approach 3. So here is k to the third plus 3. The value of x is 3 now. We substitute for 3. Must equal 16 over k squared minus 3. That's the before the last part. So the function, if it's continuous, we must equal both sides here. Equal both sides. So we multiply the top and the bottom by k square minus 3, and here is k square minus 3 to have equal denominator, then the numerator equal denominator. So x square minus 3 times that's x square minus 3 times k to the third plus 3 equals 16. Students try to do this several times and they fail to finish it and they confuse because it's you could get it through the calculator. Yeah, that's right. Let's say this is x squared minus 3 times x to the third plus 3 equals 16. Graph it and find solutions, but actually they confuse. There is another method, which is we assume that the function also is differentiable. The function is differentiable, so we could do that. And instead, so what we could do here, differentiate both functions here. The differentiation will be the limit of the derivative of x when x approaches 3 from left side, this part, equals the limit of f of x, derivative of x, when x approaches 3 from right side. The derivative here is 1, and the derivative here will be, you apply quotient rule, it will be negative 16 over k squared minus 3 squared. Now it's easy. As you see, it's easy. So if we equal both sides and solve it, we're not gonna have any value for k such as 2.0, 2.6, 8.5. So there is no such value of k. The answer of this is D. Rare to find D as answer, but in this test the answer was D.